Okay, well, we are to our second presentation, running a couple minutes ahead. That's great. This is by Rafael Nunes and two of his colleagues, I believe, from the University of Lisbon. And we'll either have the title in front of me in a moment, or I'll let Rafael read that. I don't have it in my head at the moment.
I need to press here?
To face AV on for the next presentation,
okay.
It looks like we are there. Okay. Fantastic. Tactic and API for touch and tangible interaction. Rafael?
Thank you. Hello, everybody. So I'm Rafael from the University of Lisbon. I'll be presenting Tactic, an API for touch and tangible interaction. So interactive surfaces have become ubiquitous thanks to the proliferation of devices, such as smartphones and tablets. But also, larger surfaces have grown in popularity and have also paved the way for current commercial products. So researchers, of course, have been studying different types of interactions on the surfaces for years now. So we've got, of course, touch interaction, which has been extensively studied, ranging from object handoffs to also some studies on user performance in pinch and rotation gestures, and also user identification to gather knowledge on which individual is actually responsible for each touch. So, of course, also tangible interactions have been studied, and they do add another layer of input while also getting us closer to what is the real feeling of a real-life interaction around tabletops. So many works have studied how we interact with real-life objects that can carry information along with them, like the famous Reactable, which combines an interactive surface with tangible user interfaces. And like I said, many of these projects actually become actual products like Microsoft Pixel Sense. So in more recent years, technologies allowed us to explore gesture interactions above the surface. And of course, research efforts try to complement this by combining interactive surfaces and tangible user interfaces with this possibility to use a continuous interaction space that's located above the surface. And so the fact that we have hardware and software that can support all of these things does create new and exciting possibilities, but it also brings its challenges. So this is from a personal experience. I'm kind of ashamed of this. So a few years back when we were just starting with Connect, and I especially was really a rookie in research, I was asked to control a Google Earth web application with Connect. And so basically we had this C# code for Connect, and our biggest challenge here was to actually establish any communication between our code and our web application. So the solution we came up with was, well, really crude. So we just mapped gestures to key bindings that were generated through the C# code. So basically, if we swiped left or right, we would generate those key bindings through the code. And it worked. But of course, it lacked the control to do more complex things. So it was no different from actually just controlling Google Earth with your keyboard. So no communication was actually happening. And this was actually a constant in future endeavors that we went in research. We always had some difficulty establishing communication between different components and software. There are, of course, some solutions. Then later on, when I started working on touch tables, actually, one of my first challenges was as basic as getting an element to know if it was being touched. So all I had at the time was this Tuyo JavaScript that basically gave me touch events detailing coordinates, and that was it. So I had to do all the rest by myself, even though I knew that people have been doing this for a long time, and there should be some way that I could get into that and not just do it all over again. So, of course, I started handling this information by creating a method that checked if my touch was inside a bounding box, and it worked, of course. But then I had to go into inner elements. And again, how would I know if I was touching these inner elements or the outer elements? And so I had to, again, create many methods just for these types of situations. And I was getting caught up in a lot of coding challenges instead of actually getting any work done. And so it was really frustrating because I was getting a lot of useless copied code. It was just not efficient. And so going forward, we knew that we needed some way to bridge different components and languages, so be it hardware or software, and also have a common programming environment, so that we also don't need to redo something that we already had done in the past. So our goals were to develop an API that allows easy development of applications for, while also integrating each technology and managing communication between different components. We also aim to test and validate this API for future distribution to also collect some feedback from the community. So this brings us to TACTIC, which stands for Tangible and Tabletop Continuous Interaction. It supports the exchange of information between interactive surfaces, media gestures, and also tangible user interfaces. It's web-based, which makes it accessible to what is probably the most pervasive environment currently. And it abstracts different kinds of information and provides events to developers while doing the heavy lifting of back-end data processing. And I'll show a little more of this down the line. It also runs on a browser, which makes it easy to deploy in both interactive tables and also, for example, smartphones with basically the same code. So I'm just going to delve a little bit about the architecture. So one of TACTIC's main assets is, like I said, leveraging the communication between client applications and various sources of input. So touch and tangible information are handled through Community Core Vision and Reactive Vision, respectively. And the API already has a Tuyo plugin to receive this information directly. So there's no need for any additional bridges. However, our gesture information is handled through FreeGear. I don't know how many of you know FreeGear. Basically, there was this company. They had an SDK so that you put a Kinect above your setup, and they immediately give you finger-precise representation of your hands. They actually now are known as Nimble and were even acquired by Oculus. So anyway, FreeGear was in Java, so we actually needed an additional bridge to communicate. And so we deployed the RabbitMQ messaging middleware into our system architecture. So what it does is it allows components to publish and subscribe to events, easily bridging different types of technologies and languages. And this also makes our system highly modular, since you can actually add your existing components without making changes to any previous configurations. And finally, we added a Node.js module to have communication between client applications, which in turn also provides easy development of distributed interfaces. OK, so like I said, we do provide various events and classes to developers. Here's a video. I hope I don't get too technical with this. Bear with me. So our Touchable class allows us to receive touch events. So here we see that we add the Touchable class to our div. And this allows us to bind touch events. So here we're just going to bind the touch press event. And we're going to change the color of the div to red when we touch it. Then when the touch is updated, we're going to set the text to moving inside div. And finally, when the touch is released, we're just going to change the color back to yellow and clean the text from the screen. So here we can see an example. Yep. OK, so we also have classes like movable and resizable that automatically add behavior without the need for any extra code. Other classes include rotatable, resizable above, which is triggered by a pinch above the surface, and rotatable above, which is triggered by a full hand rotating above an element. OK, so we also have object aware, which is used for tangible events. So here we can bind the object added event. So it will trigger when an object enters the element. And we're going to set the name displayed on the screen to the object ID. Then when the object is updated, we're going to set the font size according to its angle. And when it's removed, we're going to clean the name from the screen. So here we can see that when the cube enters the element, the name is displayed on the screen. And when it rotates, the font size changes according to the angle. And same goes for the phone. OK, so this is an event for tangibles above the surface. So we need init tracking above the table. And then we just bind that event. So it's the object hovering event, which will trigger when a tangible is lifted above the surface. So here we're going to bind our right hand to a big brush size, our left hand to a small brush size, And then we're going to assign our cube to the red color and our phone to the blue color. And finally, we just draw at that coordinate with that brush size and color. So here we see that when the phone enters the screen, nothing happens. But when you lift it, it starts painting above. And when you exchange hands, it actually changes the brush size. And then, like I said, the cube is assigned to the red color, and the phone is assigned to the blue color. OK, so yeah, this is the harder one. So this is our emit and receive messages. So it's for distributed interfaces. So here we have two pieces of code, one for the phone, one for the table. This is the table side. So we're going to add an object added event so that when our phone enters the element, we want to emit to the phone that it happened, and we want to emit our div to the phone to send it to the other way and just clean it from the table. So yeah, just remove it from the table. So on the phone side, we want to receive that event. And what we're going to do is, if in fact it is our phone that is inside that element, we want to add that element to our phone screen. Then what we're going to do is, if we're above the table and we touch the phone, so touch press, we just want to send that element back to the table. We also remove it from the phone to create the illusion that it was actually sent. So back on the table, we just receive that and basically add the element back to the table. OK, so it's more fun this way. Yeah. So when the phone enters, now it's on the phone screen. And above the table, when I touch it, it goes to the table. Yeah. This can be expanded for proximity-aware devices. So here we see that one phone actually keeps the element. And above the surface, they exchange the element when they get near each other. And then the other one drops in on the table. OK, so we're also able to provide new solutions by merging information. So, for example, touch interfaces are not traditionally able to detect which finger or hand is actually responsible for the touches. However, thanks to the possibility of merging gesture and touch information, we're able to provide touch events that actually detail which hand and finger are doing the actual touching. Also, tangibles would traditionally be restrained to the table surface, since the camera below cannot detect something that's not pressed against it. But we're able to actually use our gesture information to infer object positions above the surface. And we're also able to track hand exchanges by monitoring hand positions and also states at all times. OK, so a little bit about validation. We wanted to just investigate tactics ESOL running in use. So we conducted a study with 5 participants. And they were all undergoing a master's degree or PhD. And they had basically 0 experience with this type of interaction, be it touch, tangible, or gestures. So trials would start with a brief profile questionnaire and an overview of the API, explaining the basics of the documentation. And next, we would ask users to actually do a series of tasks while monitoring the duration and written code. And finally, we'd ask them to express how easy they found different aspects of the API. So for task 1, users were required to build an HTML page that displayed 3 buttons representing the colors red, green, and blue, and 3 buttons for small, big, and medium brush sizes. And the objective here was to have users build a page with no actual API code, just so that they could work on it in the future tasks. So for task 2, we had users add touch functionality, so that by touching the color buttons, the color was chosen. And by touching the brush sizes, the brush size was chosen. And then when brushing over the canvas, you would actually paint with those parameters. So next, we had them add tangible interactions. So basically, you chose the parameters with the tangibles and did the painting with the tangibles. And then we had them add above the surface functionalities. So basically, you would choose the parameters with the tangible, but you would only do the painting when above the table. And finally, we'd have them add cross-device functionality. So this time, we'd have them use a phone. The phone would have to display the color that was chosen, and painting above the table was only done when actually touching the phone screen. So here are some results. So in task 1, users were required to build the main code, thus justifying the fact that it took the longest amount of time. But it's really interesting how in tasks 2 and 3, since tangible interaction actually uses the same principles as touch interaction, code-wise, users actually didn't need to add any new lines to include the tangible interaction, and all users changed exactly 14 lines, which related to classes and events. And it's also noticeable how they took actually far less long the second time around. The one we like the most is this one, where actually users changed the painting action to above the surface. And this was as simple as adding that init tracking above the table line and just changing the event to object hovering. And so it's a statement of the effectiveness of the API, since that little change actually completely transformed the interaction modality. So finally, for the cross-device, of course, users had to add new lines of code to the phone to create a whole new page. But all users changed, on average, just 9 lines of code on the table, which only related to the communication. So to sum it up, participants' impressions were very positive, and they expressed their happiness with what they were able to achieve in such a short amount of time. So the longest session took around 40 minutes. And also, participants pointed out the positive fact that they did not need to learn anything regarding the technologies they were using to actually be able to use them. So overall, Tactic did prove easy to use, and it did promote code reuse by enabling developers also without experience on any of these technologies to implement them into their applications. So for current and future work, we know that for touch-enabled devices that don't process touch input for TUIU, events are directly handled by the browser, which makes it hard for us to actually handle the information. So for example, our movable class doesn't work on mobile browsers, since when you drag, you're actually dragging the page, and the information doesn't reach our API. So we're solving this little by little by treating the events directly from the browser, and also locking some features like zoom in and drag. Also, although RabbitMQ is good for the system modularity, it also creates a problem of having to learn an additional API to connect your existing components. So we're actually working towards dismissing RabbitMQ in favor of, for example, Node.js, which is far more accepted in the community. We feel that currently we have a limited number of gestures. So we have hand-pinched and unpinched, and also resizable above and rotatable above. And so we solved this by adding the hand moves and fingers moved events, which detail the same raw data that we use to create our events. So it's in the hope that the community itself can create events and add them to the portfolio. And finally, we're currently working on adding more sources of information to make this accessible to as many current setups and installations. So I'd like to thank you all for listening, and feel free to download and test the API. There's also some cool videos on the site, and I encourage you to email me if you're trying it out, especially if you have any problems, because I'm trying to make it easier for other people to actually use it. So thank you.
Okay, questions? I see one coming. Bjorn.
Thank you for your talk. One question I have is, it seems like you adopt a message passing framework where you pass events back and forth, and events in traditional user interfaces like web interfaces, which serve as inspiration here, are very deterministic. But as soon as you have depth cameras, touch sensing, oftentimes the data is not so clean as we would like. So there are notions of probability and noise come into play. And I wonder if you could tell us a little bit how, in your experience, how that plays out in this particular framework. There have been other people who advocate for taking a probabilistic kind of perspective from the beginning for handling all of this recognition-based input, just because the data tends to be so noisy.
Okay. Okay. I think I get where you're coming from. Our focus was more on actually handling known types of information and events. So as you saw, TUIO-based events are generally used. So we actually handle them because we know how they behave. For Connect, of course, there are endless possibilities. And so I understand what you said about probability-based. So we actually don't manage or handle the information on that sense. We just receive them and package it in a way that it's accessible to other languages. I don't know if that actually answers your question.
So I would then write that as a piece on top of your substrate, in a sense.
Okay.
Is that, I think that's the answer, right? So
Yeah.
for example, if I look at something like the Leap SDK, you probably have to write a layer on top of that filters and interprets the events that come out of it in order to be robustly usable by an application.
Yeah, we actually thought about using Leap at some point, even before using Figure. So basically, at this point, if we actually wanted to add Leap to our API, we could just put it besides Figure. So that's why I said it's modular. You can just add plugins and keep the information flowing. You don't have to just substitute or manage information in a different way. And we're actually working towards having anyone that does use the API be able to also manage that information, not just us currently. Okay?
Thank you.
Thank you.
I will ask one more question then. I was really interested by your combination of tangible and gestural interaction with the browser. We're very fortunate with the conference to have a couple large software, hardware companies who are supporting us. And so if you were able to pick any website or any web application out there and enable it to take the full potential of your tool set here, it could be Twitter or Facebook or online web-based spreadsheet or others. Do you have any thoughts which first existing kind of web-based content you might choose and why?
Well, actually, one of the things we're doing right now is just making the general navigation of the browser accessible. So we're targeting touch PCs, basically, and like I said, mobile browser touch events to make it accessible to not just touch tables, which are running our own software, wanted to be able to run it on general laptops.
This particular funder wants to see a particular application, so which would you choose?
Well, I wouldn't go immediately to social media, maybe. So you're interested in one particular website, is that it?
Right, if you were to reinvent, take some existing set of content
to
really show off the full potential of your tool set, which type of content, which website, which application would you pick and why?
Well, I think so many websites right now are already so well designed to, well, not so many, but they're designed to actually behave with touch events and not so much with tangibles, actually.
True.
And actually, they're going a little better on the gesture side than they are actually on the tangible side. So it's hard to me. I actually focus on the tangibles, and I find it's kind of sad that faced with that question, it's hard to me to actually think of how websites can behave with tangibles. Yeah, so I'm kind of not answering your question, but I'm accepting the challenge.
Exciting as well.
Yeah.
Excellent. Looking forward. Let's
Thank
give
you.
another round of applause.